Hi guys, I'm Aryan. I'm 6 stars on CodeChef and Master on Code Forces. Welcome to our channel Learn Competitive Programming with CodeChef. Every week we upload tons of competitive program related content, so here's a reminder to subscribe and click on the bell icon to stay notified. Today, we're going to discuss a problem named minimal travel time, which appeared in the March 2021 Starters contest. This is an easy problem and only requires knowledge of breadth first search. So let's look at the problem statement. The problem states Chef's college is starting next week. There are S subjects in total, and he needs to choose K of them to attend daily to fulfill the required number of credits to pass the semester. There are N plus 1 buildings. His hostel is in building number 0. Subject I is taught in building AI. After each subject, there is a break, during which he goes back to his hostel. There are M bidirectional paths of length 1, which connects building U to building V. Find the minimum possible distance chef needs to travel each day if he chooses his subjects wisely. Okay. The constraints are standard. We have 3 test cases and a graph with everything less than equal to 10 to the power 5. The graph is guaranteed to be connected and have no self loops. Okay. The idea in this problem is that the buildings form a graph. Okay. So they form some arbitrary graph. Okay. I'm just making something very rough. The graph is unweighted since all the roads have the same length. Okay. And the graph is bidirectional. I mean, all the edges are bidirectional. So the graph is undirected. Okay. Now, each class takes place in one of these buildings. Okay. So if we label the building from 1 to n, okay, then each class Si takes place in some building. Okay. Where the building is Si. Okay. So each class I takes place in building Si. Okay. Now, on each day, we start our journey at our hostel at node 0. Okay. Then we go to our first class. Okay. Let's say that it's at node 3. So we take the shortest path to node 3, attend the class, come back to our hostel, and then go for our next class from the hostel. Okay. And this keeps on happening until we go to our last class, and then we come back to our hostel finally to end the day. Now, to write this down formally, let f from 0 to I denote the shortest path in the graph from 0 to S of I. Okay? What this means is that when we attend, let's say, the ith lecture or the ith class for which you have to go to building Si, it means first you have to spend f of 0i time in going to that class, and then f of 0i time again in coming back. Okay. So basically 2 into f of 0i time is spent for each I that you attend. Okay. Now you want to minimize this. So this is equivalent to minimizing the sum for all I f of 0i. Okay. And this is for all I that you want to attend. Okay. So you have to attend exactly k classes, right? So it's pretty clear from this that what you want to do is select k classes. Let's say the classes are k1, k2, dot dot dot, k of k. Okay. You want to select k classes such that the sum from I is equal to 1 to k, and the f of 0 to ki is minimized. Now, to do this, it's pretty clear that all we have to do is find the shortest path from 0 to all other nodes, okay, which can be done easily in order of n plus m using BFS, okay, and then all we have to do is select the k classes with the shortest distance from 0, okay. So let's say that if we sort nodes by their distance, the order is 0 obviously doesn't count because it's the hostel itself. The order is 1, 3, 2, 5, 4, 6, 9, 8, 7. And we want to go for 6 classes, okay? K is equal to 6. Then we would simply select this entire block of classes, okay? And the answer would be the sum of shortest paths to all of these classes from the hostel multiplied by 2. And that would be our final answer. So this is actually fairly easy to implement as well. So let's just look at it once. The implementation goes as follows. First, we input T, the number of test cases, and NMSK, which are the number of buildings, the number of edges between buildings, the number of total classes that there are, and the number of classes that you need to attend. Okay. Then we initialize the answer to 0, which we'll use much later, but we initialize it here. And we create the adjacency list, okay? So we input all of our edges and we create this bidirectional unweighted adjacency list. Then we create a vector int ci, okay, such that ci stores all classes which happen at building I, okay? So for each I from 0 to s minus 1, we input the index of the building at which it takes place, and then into c of x we push back I, okay? Now we don't actually need the index of the class, okay? We actually just need how many classes happen in which building. But like in case we need this information, I've just done this, okay? It just so happens that we don't need it for this problem. So now we initialize an array called visited, which is a standard BFS thing for shortest paths, okay? And we initialize everything -1. Then this is just a completely standard BFS other than this loop, okay? So this loop means that when we find a node in the BFS, when we finally pop it from the queue, okay, then this node cur is basically the closest node to 0 which has not already been visited, okay? So this is the next closest building to 0, okay? Now, while this building still has classes that we have not added to our timetable, and while we still need to select more classes to add to our timetable, so while k and ccur.size, we reduce k and we remove this class from c of cur, and then to answer we add 2 multiplied by the distance to cur, okay, which is basically the distance to the class as well, okay? So this is just standard stuff, and then we output the answer. So let's just submit this once.